problem number 13, and it reads, how many positive integers n are there such that n is an exact divisor of at least one of the two numbers, 10 to the 60th and 20 to the 40th? So to start, I put 10 to the 60th and 20 to the 40th in their factored form. So 10 to the 60th is equal to 2 to the 60th times 5 to the 60th, and 20 to the 40th is equal to 2 to the 80th times 5 to the 40th. You have to double the number for 2 because 5 times 4 is equal to 20, and there's 2 2's in the 4. So then, you know that any number that's a divisor of this is going to be in the form 2 to the a, 5 to the b, and it's going to be the same for both of them. So you know the a value for 2 can be anywhere from 0 to 60, and the b value can also be. So for the first one, you go from 0 to 60 for both of them, so you get 61 times 61, and that's how many exact divisors there are of 20 to the 60th. And so you do the same thing for 20, but then this time you have 0 to 80, so you have 81. And then for 5, you have 0 to 40, and that's 41 possible terms. So multiply these out. I'll do that down here. So this is how many possible divisors there are of 10 to the 60th, and that's how many positive divisors there are for 20 to the 40th. But then you have to remember that there's some divisors that are going to include both. So to do that, I have to find the greatest common factor between these two, which is equal to 20 to the 60th and 5 to the 40th. So then you do the same exact thing that you did before. So you get 61 times 41. So these are both of their factors, and this is the one that they share. So you add the first two and then subtract the second one. And then you find that there are 4,541 possible divisors of at least one of the two numbers.